In the chapter Circles of the 10th standard, you have to learn two theorems on tangents, my dear students. Let us very simple theorems and very simple small chapter. Let us learn it quickly. See, the theorem, first of all, you note down the first theorem, statement of the theorem. It states that the tangent at any point on the circle is perpendicular to the radius through the point of contact, is the theorem. Generally, you know that we already studied in the 9th standard also. Whenever you come across a theorem will have some 3 to 4 parts in it. First of all, you have to draw the relevant diagram. Then you have to write what is data that is given. Then you have to write to prove. If at all any constructions are there, you have to make the constructions. Then you have to write the central part of the proof called as the proof. See, first of all, you draw a circle with center O. Let xy be a tangent at the point P. That is what is given to you. Data means what is given. In the statement, whatever is given, you have to write it by looking at the figure. You have to write the data. O is the center of the circle. O is the center of the circle. Center of the circle. XY is a tangent to the circle. XY is a tangent to the circle at P, which is the point of contact at P. This is what is given to you. What is to prove? We have to prove that OP is perpendicular to XY. OP is perpendicular to XY. Now you have to plan. This is a routine work. Whenever you take a theorem, you have to read the theorem, understand the theorem, write a relevant diagram like this, then write data first, then to prove. And you have to, before writing the proof, don't by-head the proof. Many students are of the habit that they will by-head the proof. Don't, never by-head. You must plan what you are going to do. Our aim is to prove that OP is perpendicular to XY. Let us think of what are the possibilities of proving this. This P is touching the circle. As XY is the tangent, it is meeting the circle at the point P. We are joining OP is the radius of the circle. OP is the radius of the circle. OP is the radius of the circle. Radius of the circle. What are the possibilities of proving this? Let us try to think. Suppose that you mark, let us make a small construction before we prove this. Let me mark a point Q on the tangent and join this OQ. O to this particular Q. You can observe. If this particular XY is cutting the circle, Q is inside the circle. Q is inside the circle, then XY would have been a secant. It will not be a tangent to the circle. And this OQ, if you observe carefully, and if you bring this OQ closer and closer and closer, this particular point closer and closer to the P, at any point, if you say except this particular OP, this point, if you draw here, draw here, draw here, draw here, if you go on joining them, definitely OQ will be what? OQ will be greater than the radius, isn't it? So radius will be here, radius will be here. And except point P, even here also, if you take the point Q anywhere here, what you observe is this particular OQ will be always greater than OP. Means what? Either you take on the right side of this tangent or you take on the left side of this tangent. This particular OQ will be always greater than OP, either from the right or from the left. You can conclude that this particular OP is the shortest distance from the center to the circle. Right? In day-to-day life, what do you mean by shortest distance? Remember, shortest distance from any point to any line is always a perpendicular. Therefore, you can conclude that OP is perpendicular to XY, logically. It's a proof, logical proof. Let us make a small construction and write whatever we discussed. Construction. Draw, mark a point, Q on the tangent xy other than P. Yes. Now, whatever we discussed, we will try to write logically the proof of it. The proof is that Q will have three possibilities. If it is on the circle, it would have been radius. If it is inside the circle, then this particular xy becomes a second. If this particular point Q is inside the circle, what would be the xy? In that case, xy would have been second. Means when it is outside the circle, Q point is outside the circle, if you move this particular point Q closer and closer to P, definitely this OQ will be always greater than R except at point P. Even if you take here, anywhere here, this OQ will be greater than this particular radius except the point P. Okay. If Q is, let us write the logical proof, if Q is inside the circle, Q is inside the circle, xy would have been second, would have been second. Hence, Q is outside the circle. Q is outside the circle. Mark this. I will rub this part and I will continue the statement of the proof here. Logical statement. Just you have to write logically, need not do any mathematical work. Just you have to present logically outside the circle. Q is outside the circle. And if you take a point at if Q is taken at any point other than P, OQ is greater than OP, that is radius. Therefore, OQ is always greater than OP. Except P, all other distances are longer distances. Means what? OP is that implies OP is the shortest distance. OP is the shortest distance between center of the circle and tangent. You remember one thing in geometry, the shortest distance between any two lines or a point and a line is always a perpendicular. Therefore, by geometry, you can say that OP is perpendicular to the tangent XY. Hence the proof. If you write this much, it is sufficient to score 3 marks. Suppose the question appears for 3 marks to prove this first theorem. Note down the statement. We will continue with the second theorem after this.